answers to these questions. We seem to face another limit of science, its inability to answer these ultimate questions. Now, there are scientists and philosophers and others who will object to this. They will say that science can answer some of these questions, and as a matter of fact already has answered them. Let me give just one example of this. It's from a neurobiologist back in the Netherlands, a colleague of mine at the University of Amsterdam. And it has to do with the question whether there is a meaning to life. He says in evolutionary biology, the notion of chance plays an important role. Mutations in the genetic makeup of organisms are generally referred to as chance events or chance occurrences. Now, a fair number of people assume that chance is the complement of design. And on the basis of that assumption, they conclude that mutations are undesigned, and then merrily or sometimes melancholy go on to claim that life is a meaningless affair. That there really are no such things, he furthermore claims, that indicates that there are no such things as morally good and morally bad actions, and that human beings simply have to dance to the rhythm of their genes. This line of thought calls for a lengthy response that, unfortunately, I can't give now. Instead, I offer two short remarks. First, this line of reasoning is confused in that it doesn't properly distinguish between various notions of chance. I think you should distinguish at least 9 or 10 different notions of chance. Now, when biologists say that mutations are chance events, what they mean by that is, among other things, that mutations don't result from some sort of prospective calculation on the part of an organism to the effect that, given the current local environmental situation, the payoffs of a certain kind of mutation would be great. The mutation doesn't occur because it is fitness enhancing. But of course, when it's claimed that life is meaningless, what is meant is not that mutations don't occur because they are fitness enhancing. Something else is meant. This brings me to the second very short point, that once one acknowledges that there are these different notions of chance involved in various discussions, then one also sees that it's entirely unwarranted to claim that because mutations are chance events, life is pointless. That's a gigantic step from biology into metaphysics. This further claim simply doesn't follow. Or perhaps I should more cautiously say, it only follows when one helps oneself to a number of assumptions, none of which itself is the result of scientific research. So I submit that science is limited in the sense that it's unable and unequipped to pronounce on ultimate matters. I've learned from many conference experiences that among American academics it's not unusual to drink water while presenting. So I feel free to do that, whereas in my own cultural environment it would be considered somewhat cavalier with respect to the audience, somewhat expressing a lack of respect. But since I'm here among you, I feel entirely free to go about in your ways, and knowing that I don't express any disrespect. A limit from inexplicable brute fact. Next to ultimate questions, there are other questions that science cannot answer. In a sense, they are ultimate too, but not in the existential sense or in the existential way the questions in the previous section were supposed to be. As I said, scientists sometimes proffer explanations of phenomena. Now, one important type of explanation involves citing a general law. That heated air moves upwards can be explained by citing Boyle's law, or as we say at the other side of the ocean, the law of Boyle-Gay-Lussac. And an explanation like this consists, at least in part, in subsuming a certain phenomena under a universal law. And such kind of explanations are obviously valuable. They add to our knowledge and understanding of the world. But such explanations leave unanswered the question why those particular universal laws hold and not others. Surely, some laws can be explained by reference to other, more general laws. And those laws might in turn be explained by yet more general laws. But there is an end to this. There comes a point where there is no next higher level law, and where we face brute facts, that is, facts that cannot be explained by reference to laws, or laws of a higher level of generality. The set of brute facts comprises not only universal laws, but also the so-called universal constants, such as the gravitational constant. These constants have specific values, values for which it seems no further explanation can be given. They are brute facts. Other brute facts are, I should say, of a more homely kind. Consider an apple. We can try to explain why this apple tastes the way it does. Such an explanation will no doubt make reference to taste buds, to the way they are affected by the physical properties of the apple, to neurological impulses that are transmitted to the brain. And such an explanation will also make reference to laws. But such an explanation leaves unanswered the question why this particular stimulus, this apple, gives rise to this extremely hard to describe but all too familiar sensation of taste. Scientists may be able to tell something informative about neurological transmission of impulses, but they can't, it seems, explain why such and such impulses cause such and such taste sensations. As Thomas Reid has it, and that's a quotation on the handout, no man or woman can give a reason why the vibration of a body might not have given the sensation of smelling, and the effluvia of bodies affected our hearing, if it had pleased our Maker. In like manner, no man can give a reason why sensations of smell, or taste, or sound might not have indicated hardness, as well as that sensations which, by our constitution, does indicate it. Here again, science encounters an inexplicable brute fact. The point I'm navigating towards here is that brute facts constitute a limit of natural science. The natural sciences, as we now know them, have a limit in that they cannot explain certain brute facts, even though these facts are invoked in explaining natural phenomena. And this is another thing I'm going to exploit in the final section. I now move on to a limit from norms for theory choice. Scientists devise hypotheses and theories, and they also evaluate them, comparing and contrasting them with alternative hypotheses and theories. Scientists make, and they have to make, theory choices and theory evaluations. And those choices and evaluations have to be made in a reasoned way. But when is a reason to accept a particular theory a good reason, and when is it a bad one? This is the subject matter of what's usually called the theory of scientific rationality. And it's generally agreed that certain reasons are of a bad kind. That a theory gives you a headache is no good reason to reject it, and that it boosts your popularity if you adopt it, no good reason to accept it. So there are norms for good and bad reasonhood when it comes to theory choice and theory evaluation. Now it could be argued, as one of the Calvin philosophers, Stefan Dijkstra, has done, that such norms lie on various levels. There are, he argues, first of all, norms on a theoretical level, one example of which is simplicity, which works as follows. Confronted with different theories with respect to the same subject matter, this norm says that if theory A is simpler than theory B, A's being simpler than B is a good reason for accepting A, or for preferring A over B. And second, there might be norms, or there are norms, for theory, choice, and evaluation on a methodological level. One example is induction. Given two different theories about the same subject matter, this norm says that if theory A is based on inductive inference, whereas theory B only on, I don't know how to pronounce that word, casuistry, just casuistry, then A is to be preferred over B. And finally, there are norms on an axiological level, a level of values. One, as Steve Dijkstra calls it, has to do with the height of a theory. An instance of this is, says Dijkstra, Robert Boyle's adherence to corpuscular or mechanical philosophy, for the reason that corpuscular explanations are exceptionally satisfying to the mind, much more so than Aristotelian explanations. Given two theories, only one of which involves corpuscular philosophy, this norm says that the one that involves that philosophy is to be preferred over the one that does not. In order to be able to see what this has to do with limits of science, it needs to be noted that all the norms mentioned so far can be, and in fact have been, contested by scientists and philosophers alike. On the theoretical level, it has been contested that simplicity should function as a norm. Thomas Reid again, for instance, held that if we conclude that nature operates in such a manner only because to our understandings that appears simplest, we shall always go wrong. A further problem with simplicity is that arguments for the conclusion that simpler theories are more likely to be true, such as Richard Swinburne's arguments, have met with stern opposition. And on the methodological level, some have argued that the norm of induction itself is deeply problematic, for induction itself is deeply problematic, as Hume and many in his wake have argued. And finally, on the axiological level, it has been contested that the corpuscular theory is higher, or that it's intellectually more satisfying than, for instance, Aristotelianism. The fact that theory choice and theory evaluation is informed by various contested and contestable norms indicates, I'd submit, another limit of science in the following way. Science itself cannot tell us what the proper norms for theory, choice, and evaluation are. It isn't that scientific research brings to light which norms are the ones that should regulate our choices and evaluations of scientific theories. All kinds of extra scientific convictions and beliefs come into play here. And this is another point I will be exploiting in the final part of my paper.